Good morning, good afternoon, good evening. Welcome to the TrueSTUDIO webinar series. We're so glad you could join us today. Today we're pleased to present a joint webinar with ST Microelectronics on how to work with CubeMX and TrueSTUDIO. I am your host, Stephen Martin from Atomic. Presenting today are Daniel Favark and Laurent Dessaigne from ST Microelectronics and Matthias Norlander from Atomic. This will be a live demonstration for approximately 30 minutes. After that, we'll answer your questions. Before we get started with the demonstration, I've asked Laurent to give us a short introduction to the STM32 ecosystem for software development tools and how this fits with Atomic TrueSTUDIO, so that we have a good understanding of the purpose of the tool and how it can be used to assist you in your development. Laurent?
So hi everybody, my name is Laurent. And I am in the marketing team of the microcontroller division in ST, the one handling the STM32's microcontrollers. So I'm leading the ecosystem offer, and the ecosystem is all about giving to the developers what they need to make their developments. And I guess that most of the attendees of this today call are developers. And as developers, you manipulate every day those software tools on your PC in order to create the images that will match your application on the microcontroller. So the today call is about software development tools. So about software development tools, we tried to put ourselves under the skin of the developers, and we propose a flow in 3 main steps. So the first step is about configuration of a microcontroller. Configuring a microcontroller can be somewhat difficult. There are multiple choices, and those choices might have impact on some other possibilities. And therefore, a tool could be easing your work in order to configure properly an STM32. So we propose one tool for that purpose, which is called STM32 CubeMX. And the goal of this tool is to handle this configuration in a graphical way. And once you are happy with your settings, you can generate code that will be matching your choices. And this tool is called STM32 CubeMX because it's part of our initiative that was announced in 2014 called STM32 Cube. With this tool on the PC side and embedded software bricks on the STM32 side, that is portability from one STM32 to another. So this tool will be able, with this tool you will be able to configure the STM32 and generate code, C code that will be matching your initialization choices, matching those embedded software bricks. Then the next step is to handle this initialization code, and this is where it's very interesting to work with an IDE like Atomic to add on top of initialization code the code that will be matching your application, and then to enter the standard build and debug mechanism. And the final step, that can be a final step that we propose to the customers. That is the monitoring. Indeed, there might be situations where debugging from an IDE might not be the ideal situation. For instance, if you have a motor control application, it might not be a very good idea to have a breakpoint right in the middle of a regulation algorithm that could have some impacts on your motor, for instance. So this kind of tool like STM32 we have will be helpful in such case, as it can spy the behavior of your variables while the program is running. So it's going to help fine-tuning the behavior by monitoring how the variables behave over time. With those 3 steps, we think that we've been covering most of the developers' needs in terms of software development tools. And Daniel is going to focus on the left side, so in the STM32 CubeMX part, and how it can be used, how it can generate code that would be matching Atomic TrueSTUDIO for being used on top.
Thank you, Laurent. I'm Daniel Fauvarc. I'm part of the development team of STM32 CubeMX. And so what I'm going to present today is STM32 CubeMX integrated with Atelier TrueSTUDIO and how the two work together. So the first thing you want to do when you start CubeMX is choose the MCU that you want to work with. So you have several ways to choose the MCU. Either you choose using selection criteria like the series. I can use an F4 series, a specific line. I want a specific package. Or I can choose here on peripheral selections, which means that I want to have, for example, Ethernet and DSI host. And immediately I see the peripherals I can use, the MCU, sorry, that I can use for this set of peripherals. Today, I'm going to start on a board. So we have all the STM microelectronics board integrated. So I'm going to use the Nucleo 64 on the F4 series. So I have 4 boards here. The one I'm going to use is the first one. And the advantage of using the board like that is that it comes with a preset pinout. So the signals here that you see in orange means that they are allocated on the pinout, but currently I don't have any IP using those signals yet. So this is the next step I'm going to do. So what I want to do is use a nice feature that we have on the Nucleo, which is the virtual compare. It's the ability to send through an USART message and then get it on the COM port on the PC directly. So it's an easy way to do printf. So in that case, on that board, is those 2 signals that are used here. It's on USART2. Let me set up that. And for the purpose of the demonstration, I'm also going to demonstrate how we can get a message on the Atelier console. So to be able to do that, I'm going to enable the debug traces, and I will have those 4 signals allocated. Before we go through the actual demonstration on the board, I'd like to show you what can be done with the clock tree, for example. So I'm going to enable the USB, and immediately I see that there is a problem with the clock here. So I switch to the clock configuration, and I'm going to automatically resolve my clock by just hitting a simple button. So CubeMX really helps you configuring your system and does everything for you. For example, if I want to run at 84 megahertz here, let's save the project. If I want to run at 84 megahertz, it's going to try to find the different clock source that can be used to have the core at 84, and then respecting the constraints here on the USB for having the USB at 48 megahertz. So let's go back on the pinouts. I don't need the USB anymore. And on the RCC, I'm just going to use the internal clock tree and use 16 megahertz. Okay. Then I'm going to go on the configuration side. I want to configure the USART, and I want to configure it with a baud rate of 9600. Okay. So you have here all the configuration of the peripherals. You can even define a user constant here. For example, I can define my baud rate as baud 9600 with the value 9600, and then I'm going to use it here as a constant that will appear in the code. I want to print a message on a regular basis, so I'm going to enable the time to and having an internal clock source for the timer. Go back to the configuration, and I want to have a tick every seconds. So what I'm going to do is configure the timer so I have a counter period of 1000, prescaler of 16,000, so I have a 1 second tick. When I've done that, what I'm going to do is setting the project settings. So my project name is going, I have to assign a name. I'm going to select the toolchain here. The toolchain is going to be TrueSTUDIO. You see here a generate on the root here selection box. You want to use that by default so that the project files that are specific to Eclipse are generated at the root of the project, which is the default in Eclipse. In that case, everything will be correctly generated, and you will be able to integrate your generated sources into a source code management system. There are two parameters here that are important, is the minimum heap size and stack size. CubeMX generates by default a linker script with those information in it, and so it's important that you configure this information in CubeMX, because each time you regenerate, it will be overwritten. In the advanced settings, I can choose the order of the initialization. In this case, this is not very useful, but for example, if you have a certain IP that depends on the initialization of another IP, then it may be very interesting to order here the initialization calls. You can even choose to not call the function in the main. So we will generate the init function, but we won't call it in the main. So you can call it whenever you want. Okay. One thing that I didn't do here in the timer that I should have been done is configure the NVIC, because I want to have a global interrupt and being called back on an interrupt. If you want, you can also configure the DMA settings. So all the parameters or your IP can be configured here. So what I'm going to do now is generate the code. If you don't have locally the library associated with the SERI, it will automatically download it for you from the ST website. So you don't have to worry about that. It's going to be fully automatic. So now I'm going to switch to the project view and the Project Explorer, and I have my project here that is automatically included in the workspace. So everything here has been generated. For example, if I open MX Constant, I see that I have my boat 9600 that has been generated that I can use in the code. I don't know if you've seen, but in the pinout here, we have some labels. B1 for the blue push button, or LED something, LD2. Everything here, you can find it as constant, B1 pin, B1 GPIO port. So it's very easy to reuse then in the code what you define as label in the pinout. In the main.c, here you have some section, user code begin, user code end. This is where you want to put your code. So in our case, we want to do printf. So first thing I'm going to do is to write the to add the include files. Then I have a zone for the private variables. So what I can do is copy the private variables that I'm going to use. Okay. Then you see here the main code. So the main code, if you want to do something before the init, you have a user sections, but I don't want to do anything here. you see the call to the different GPIO init, UseArt init, time2 init. And then I can put my code. What I want here to do is to start the timer. So I'm called back in the interrupt. So I put it here. And the advantage here is that if I regenerate the code using CubeMX, all those code that is being inside those banners is kept. You see that the system clock config has been completely automatically generated for you. There is nothing where you have to do here. Same for the timer, same for UseArt, and for the GPIO. What I'm going to put here is the code that will be called when the interrupts arrive. And just to show you quickly, here the code of the interrupt has been automatically generated. So I have a SysTick handler for the HAL SysTick. And there is a time2 RQ handler for the timer2 handler that will call the HAL team ERQ handler function. And the HAL team ERQ handler function will call me back in that period elapsed callback. So this one is a very simple one. I print a message on the virtual compare, and I do a printf. To be able to do a printf, I need to customize where the printf is going to be sent. So in order to do that, I have to customize a minimal system call implementation. So I have to customize the syscall.c. I'm going to open the syscall.c, and I'm going to change the write implementation here to send the message to the ITM. Here we are. So very simply, I just loop here and send characters on the ITM. This way, I will be able to see what has been sent on the console, on the Atelier console. What you want to do also on the project is to customize some of the settings. So one very important thing is the optimization here. By default, we generate on optimize for size. If you want to debug and be able to step very easily during in your different lines of code, I recommend that you put none at the beginning. Then of course, when you are on the final generation, you want to optimize for size. So I'm going to apply that. And then on the run debug setting, if you want to be able to see messages that you've sent with a printf, you need to enable the serial wire viewer and put the core clock. I have a core clock here at 16 MHz. Okay, so what I'm going to do, I'm going to build. I made a mistake because ITM sensor is not known by default, so I need to include a .h file, which is the definition of the ITM sensor. Okay, here we are. So now I can debug directly on my board. I have a board physically connected on my system. You cannot see it, but you have to trust me. There is an actual board here. and I am at the first line of my code. What I want to do is I want to configure the single wire viewer console so that I can see my, my printf. So the only thing I have to do here is configure the ITM stimulus port. Just to configure the port 0, hit OK, start the trace, and then normally when I resume, I should see that the STM32Cube rocks. So now I want to pause. I'm going to maybe put a breakpoint in my code. I resume. I can see that I'm stopping my breakpoint. I can step over, and I should see here that I have my message. So very simply, the combination of CubeMX and Atomic helped me to really debug, configure the initialization code, very easily concentrate on my user code because that's where is my value, my added value, and then debug everything, and simply, if the debug is not enough, print elements on the console. That's all I wanted to demonstrate today. So I'm going to give it back to Stefan.
Danielle, thank you very much.
Welcome.
So we're now going to have an opportunity to answer your questions live. You may have questions about information that Danielle has presented, or you may also have other questions you came prepared to ask. So please use the question box, and they will be queued up for us so we can answer them during this time. I think some of you have asked if this will be available offline, and the answer is yes. You may have received that response, but we want you to know that we are recording this, and we'll make that video available to you after this presentation. So there are several questions here. The first question is, when regenerating from CubeMX, is the code added in italic kept intact?
So maybe I can take this one. The answer is yes, as long as the code that you've added is inside the banners. You have banners, user code begin, user code end, and as long as you put the code inside your banners, those banners, it is kept. Also, you can add other files, and we don't touch those other files.
Okay. Actually, there are several questions people have because we have two versions of TrueSTUDIO. There's the free version, and then there's the pro version. And we want to make it clear this is available in both versions. So CubeMX can be integrated in either. Some of you have asked about how you install it. Matthias, do you want to take that? How do you install CubeMX inside TrueSTUDIO?
Sure. That's quite easy. If I'll take over I'll make myself presenter. That makes life a little bit easier. So you'll be seeing my screen now, I hope. In order to install CubeMX Eclipse plugin into Atomic TrueSTUDIO, it's quite straightforward. You go for help, install new software. Then you need to set up a repository. STM32CubeMX, or this is just a placeholder in order to be able either to download a plugin from internet or to find one which you have downloaded locally. So in this case, I'll just go for an archive file I have downloaded. Let's see if I have this already somewhere here. So I think the file is named something like that. And it's available from ST's webpage. I can find that for you, STM32CubeMX. And you go here, will see, STM32CubeMX is available both as a standalone tool and as an Eclipse plugin which integrates into Atollic TrueSTUDIO. Let's see if we can get a connection with the website here. And by entering this way, you will download the standalone version here. What you're looking for is this one. It says Eclipse plugin. So go there, and then at the bottom of this page, you will find, well, let's wait and see. Here, this is the file you're looking for. So that's the software you're supposed to download. Well, you have that downloaded. You just go and point it out the way I did here. So I have it there. I open it. Now I already have this installed in my IDE, so I'm probably going to get some complaints at a later stage. But what you do is just to check those boxes and then move through all these steps, accept some license agreement, and then you're done. The IDE needs to be restarted and CubeMX is available. Then you need also to find it in the IDE, and that is done by going to Open Perspective, Other. This is how you do it the first time, because it will not be available up here to you the first time you open Perspective in a new workspace. So go for Other, and there you find it. And there we are. Yes. Do we have more questions?
Yes, we have quite a few. So a couple of people have asked the example you presented today, Danielle, is that available? How does someone find that example, or is there a way to make that available to the audience?
I can make it available to the audience, no problem.
Okay, so you can make it available to us, and we can email it out to the attendees.
Absolutely.
Okay. What's the difference between the standalone version of STM32CubeMX and the Eclipse plugin? Is there any difference?
There is actually no difference. It's exactly the same tool, exactly the same set of features. It's just a different packaging. One is packaged within Eclipse, one is has a standard installer. But inside, it's exactly the same functions.
Excellent.
Okay, I found a question here also, which is perhaps good to clarify. Can we use STM32CubeMX in Atollic TrueSTUDIO Lite? Because TrueSTUDIO comes both as a free version and as a commercial version. And yes, the answer is yes. We don't care if you use it in the free or the commercial version. That's up to you.
So there are several questions about example projects. Do Matthias or Danielle want to explain that?
I can make an attempt. Yes. So the CubeMX plugin here, or tool, yeah, that's a graphical tool for us, but it operates on some resources from a repository. So CubeMX not only helps you graphically to generate configurations for projects, it also helps you keep firmware packages up to date. So let's see if I can navigate this tool. Here you have the possibility to check for updates. So I can check for available new versions of different device family firmware packages. So I've been lazy. I haven't downloaded the latest versions for the STM32 L1 and L0, which are available. Let's check for the updates. Install new libraries. Here we can see what I actually have. And as you see, for each family, here is for the F7, here is for the F4. We have several different revisions. So this is a way to keep fixing bugs and releasing new example projects. New boards come along for different families and need example projects for those, etc., etc. So here's a whole range of different revisions available for the different device families. Now then the question is, which we shortly will come to, what does this include, and are there any example projects? The answer is yes. Let me see here. So how do I find where these packages are downloaded? By default, they end up in the Windows users folder, then in my user folder, and there's a folder called STM32 CubeMX, or Cube, and a repository. So this is where the tool downloads the latest releases of peripheral driver packages. As you can see here, you can unzip them. Perhaps they are automatically unzipped. And what then, are they automatically unzipped, Daniel? Do you know that?
Yes, they are. They are.
Okay.
Actually, when the CubeMX, the updater part of the CubeMX downloads the firmware library, it keeps the original zip file, but it also automatically unzips, because this is where we in CubeMX get the HAL part of the project. That's where we copied it from.
Okay.
For just to make it clear, the location of the repository is something that is configurable. So if you want to share the repository between several users, you can easily configure that in the updater settings.
Okay, nice. One always learns something during a webinar. So if I move into this firmware package, then here you see the structure: documentation, drivers, middleware, projects, and utilities. The actual question which was asked like 5 minutes ago was, are there any example projects and how do I work with those? And now I'm slowly getting there. There are projects in this folder. So we are in the F4 device family package. I have an F4 discovery board here at my desk, so I'll move into that folder. And here you see examples on 3 different levels. Examples here are for peripherals. If you want to learn how to configure a certain peripheral, this is the way to go. So if I move into ADC, that was perhaps a poor example. You will see a number of different examples where timers, etc., are set up in different ways. There are also demonstrations which are bigger example projects, and I think the applications may be the biggest ones with the most peripherals combined, or if it's vice versa. Let's just make an example here. So I take a timer example, and here you will find that for TrueSTUDIO there is an example project. I go in here, here are the project files. Let's close this, move back into the editing perspective. Let's import that project. I'll use the import wizard by right-clicking in the Project Explorer, import, general, existing projects into workspace, select root directory. Here I will simply take this path, copy it, and paste it here. And then finish. Don't use copy projects into workspace, because these example projects uses virtual folders, and I think that will destroy the example project structure. So here is now my example project, and I should be able, if it's not the curse of the demo, so to speak, to build this project and have it running within a minute or 2, if I know this. So there's my build project. I hope that answers the question. There are not example projects available for all boards in all device families. This is continuously being worked on. Yeah.
Okay, I have a question here. We'll see if the panelists can answer it. Is there a possibility to configure deep sleep or power down modes directly out of CubeMX? Especially the possibility to define wake-up interrupts for power down modes.
I think I'm going to take this one. So unfortunately not today. We don't manage that. It is currently in the plan. I don't give you an exact date when we will be able to configure that, but this is definitely in the plan.
Okay. Someone's asking where they can find the CubeMX reference manual. Is that something we can send out to the group, a link for that?
So there is a CubeMX user manual, and Matthias, if you want to switch to the CubeMX view and do simply help F1. Voilà.
Ah, oui.
You have immediately the user manual. So there is no reference manual, but there is a user manual that is directly accessible from CubeMX, or you can download it from the web page.
And this differs from the getting started because this is only for F4?
That's correct.
Okay.
This is the user manual for SM32 CubeMX that explains the different functions of the tool, and that has at the end some tutorials. If you see chapter 6, 7, and 8, you have so 3 tutorials on the ways to configure the system. There's a tutorial on the power consumption estimator. It's an additional tool that I didn't show today, but it allows you to define the different steps of your application and then get a feel of what would be the actual consumption of your application. So you don't have to extract the information from the datasheet, do your own Excel spreadsheet. It's a completely automatic tool for that.
All right, we're getting some very detailed questions. I'm going to throw this out to the panelists. Is there any way to change CubeMX generated variables to a username without having to search and replace in the Italic IDE?
You can, in the CubeMX tool, once you've defined define constants, you can choose whatever name you want. The name of the functions generated are fixed name and they cannot be changed. The things you can change is the constant. You can also change the name of the labels in the pinout to whatever you want. But there are some things that are hard-coded and which are the name of the functions.
Okay, thank you. Here's a TrueSTUDIO specific question. In TrueSTUDIO Lite, can you build release instead of debug?
Yes, it depends on what you mean with the question. With release, my interpretation is that they are looking for building a binary with higher optimization and less debug symbols. And yes, you can. Let's see. I have not generated any project with CubeMX here. I'm simply using an example project that we imported from the Cube package. And as you see here, it only includes one configuration called the debug. So what we can do is to, if you click here, select your project, click there. That means manage build configurations. And then you go for a new build configuration. So let's create one. We can call it release. Release build config, whoops, higher optimization level. I will base the settings in this new configuration on the existing configuration already called debug, so I get the include paths and the symbols across at least. That saves me some work. I'll click OK. Then I forgot to enable this new configuration, which I should be doing. Otherwise, I will not be building the new one. Oops, I even forgot to create it. Open new again, release. Okay, so there we have it. I'll set it active. Now this is the one that is going to be built when I build. Now I go for build settings to manage the build settings for the release configuration. I'm going to choose, was that because I clicked cancel? 1 second. Yeah, sorry. Let's do like that. Debug, OK, and OK. Now we have a release configuration. So I select my release build configuration. I go to tool settings. And here I can now change the optimization level. Optimize for size, optimize for speed, etc. Debug should be, in our opinion, set to 0 by default, because otherwise the debugging experience will be difficult to understand, because the source lookup will not work. So it will look as if you're jumping across different instructions in your application when it's actually not, just the debugger not understanding. The ELF file is not matching up because the debug symbols are not available. So I'll save that to the debug build configuration, and for the release one I'll set that to OS. And now let's make sure it's again set active and click OK. Now I can build a release build configuration. You see the folder here. And that gives me a release candidate binary. I hope that answers the question.
Thank you. So we have a question I'm going to toss to Laurent. Would you comment on the current state of CubeMX support for the ST product line?
So yeah, actually I already answered here by chat. So Cube is currently available for the whole STM32 portfolio. There is no exception now. I mean, it was started in 2014 and it was step-by-step deployed, and now it's fully available.
Excellent. We have a question, I guess this is for Danielle. What is the best way to migrate from standard peripheral to Cube HAL?
Yes, I guess Laurent could take it also.
Yeah.
I'll let you answer, Laurent. Maybe I can complete after.
So currently there is no direct porting from SPL to HAL, simply because HAL is slightly, let's say, above in terms of abstraction. For instance, the HAL is handling in one single calls, for instance, the UART initialization plus DMA and interrupt handling, while with SPL you have to handle that fully on your own. So yeah, you see it's slightly upper level. So this makes it quite indirect in terms of porting. It requires some effort in order to port from SPL to Cube. However, there are two items that could be interesting to consider. Already in the past, I mean, between two SPLs, it was not direct. From one series to another, SPLs were different, so you had a porting effort anyway. So here, if you decide to switch to Cube HAL, it's one porting effort, but further porting will be made easier. And second point to mention is that, okay, we've been hearing the feedbacks on Cube HAL that was set slightly upper layer, and some people stating that they were willing to have something that was lower layer. And actually, we are in the process of creating and deploying what we call the STM32 Cube low layer, and that will be that is an ongoing project that will be covering this year and certainly beginning of next one. And that will propose another point of abstraction much below, with some easier way to switch from SPL to this new Cube low layer proposal.
Okay, thank you. Sorry for the delay. I'm looking for other questions that have come in. Do the panelists see any questions they want to answer? Our audience is quite active with questions, and there's so many now that we're trying to take time to understand them and respond. All right, here's one. Why don't all the peripherals available show up in CubeMX? So, for example, the color LCD is not available for the specific STM32L152D eval board. I don't know if this is a technical issue or whether it's a CubeMX.
No, normally we show all the peripherals available for a specific MCU. That said, if you look at the board selection, some boards don't have LCD. That's why it's not a criteria. The criteria that you have on the board is more the features that are enabled on the board than the actual peripherals that you can see on the MCU. So I know it's maybe a little bit confusing because it's at the same place, but it's not at the same level. What we display on the board filters is really the functions that are present on the board. So, and on all the different boards that we have, you always have access to the board pinout using direct wires. So if you want to add your own LCD and stuff like that, this is definitely possible. I recommend that you switch to the MCU selector view if you want to have the filter based on peripherals names.
All right, thank you. And for all of you that are asking about this, we will make a video available this session. We'll send you a link to that sometime after the presentation ends so that you can watch it at your leisure and go through it carefully if there are things you think you missed. So, Matthias, I passed a couple questions to you. Can you see them on your screen?
Let's see. Yeah, here is one. How do I migrate from IAR to Atolic? I want a hex file output and I use ST Visual Tools. When I first used MX Cube, it did not work. Does it work now? Well, let's start. It feels like this is a lot of questions baked into one question. How to migrate from IAR to Atolic? Well, we have an application note describing the procedure. Let me see if I can just find this information, or at least point in the right direction. So what you'll need to do is to create a new project for the device in Atolic TrueSTUDIO. Then you should copy the resources across from your IAR project and set up a corresponding build configuration in TrueSTUDIO for this project. Then it's also a matter of converting the linker script, and if there is any specific compiler intrinsics that are only relevant for IAR, may need some modifications for GCC. So this is described in the IAR E1 to TrueSTUDIO migration guide, which can be downloaded from here. Then, if I interpret the question correctly, they also wonder how to create another output format of the build output, because by default we generate an ELF file. And that can be done by going into the build options, and here in the other output format it is possible to convert build output to something else, Intel hex, etc., etc. So that's how you do it. For all you people who are new to Eclipse and TrueSTUDIO, you should know that if I make this setting right now, if I confirm that, it will only be applied to the release build configuration. So you may be a bit surprised when you build this with the debug build configuration and the hex file does not appear. So I should perhaps be doing like this, select all configurations and then do like that. Apply, OK. That saves you some time and frustration. Let's just see if we can build. What did we build? I think we built the release, and there's your hex file. Yep. That was the second of this question, and I use ST Visual Tools. I don't know what ST Visual Tools are. Perhaps, Daniel, do you know what that is?
I know about SVD, but is it the same?
No idea. I think that the one shooting the question perhaps need to clarify, and perhaps we can then clarify.
Okay.
Yeah, that's the main points of the question.
Okay.
Here's another question also. How do you configure the location of example projects in CubeMX? Yeah, I think the question refers to how do you configure where to download the firmware packages.
So there are two elements to that. If you switch back to the CubeMX view, and you can do project settings. This is where you will be able to give a project name and project location. When you start the project, you have the possibility to change the project location. Otherwise, you have to do save as to change the project location. So you have a full possibility to change that. And then for the download of the libraries, you will have to do help updater settings. And here is where you choose the repository folder for the libraries.
Okay.
And by the way, if you switch to connection parameters, this is where you want to configure your proxy configuration if you have any proxy. And when you've done that, you have to click on the check connection button to for those configuration parameters to be taken into account, and then have the possibility to download new firmware.
Okay. Thank you.
Okay, I have a question. We were shown that the definition in Cube can and will create hash-defined macros in the code automatically. If those macro names will get changed, will those names get pushed? And the answer is yes. Next time you do code generation, the names of the macro will be changed. And of course, if you use the macro names, the old macro name in your own code, it won't be changed. We don't touch the user code. We only touch the code that we generate.
Here's another question. Is CubeMX fully functional in Atolli TrueSTUDIO Lite, or are there functional limitations? The answer is no, there are no functional limitations in CubeMX. Those are only in TrueSTUDIO, and yeah, those can be read about on our website, where we compare the Lite versus the Pro version of TrueSTUDIO.
So we have about 5 minutes left in our time. If there are additional questions, please get them in now. Here's a question. Are there hardware libraries which will work with CubeMX and FreeRTOS?
The HAL library is compatible with FreeRTOS. One thing that is important important when you configure FreeRTOS is that the HAL library needs a tick, which is by default set to the sysdic. Maybe Matthias, you can show it if you hit cancel here and you select FreeRTOS. Enabled. And then you go to sys. You go to the sys peripheral. Okay, you have to choose here a time base which is different from sysdic when you have FreeRTOS. Why? Because in that case the sysdic is reserved for FreeRTOS, and as you need the time base for HAL, you need to choose, for example, a timer. There are several possibilities for the time base for the HAL. So if you choose one timer, CubeMX will automatically configure the timer and reserve that timer for HAL to configure the sysdic. So it's recommended to use a timer that is not doing a lot of functions because it will be reserved only for the tick. And another thing that is interesting to mention is the NVIC configuration. The priority will be automatically set if you are in the FreeRTOS environment, because all the constraints, there are some constraints on the priority of the interruption when you are in the FreeRTOS environment, and all that is taken into account by the tool. We try as much as possible to take into account all the different cases where the configuration is not possible, or you need to do special things for the configuration. And that's why with the tool we hope that we have covered always that we will generate always a configuration that will work. That's actually our goal.
Thank you. So some have asked if they can get additional training on using CubeMX, and I understand that if you contact your local ST representative, there are trainings available, so work through your local ST office and they can help you out with that.